What's up everybody, welcome to my channel. Today I'm going to be building a reverse gold plating cell. I'm doing this because trying to process the gold plated stuff using nitric acid creates a lot of metal waste and can take a really long time. So a cell like this should make things a lot easier. Well, should. But anyway, the first thing on our list is a Pyrex baking dish. The kind with thicker glass is preferred, and if at all possible, you want to try to find one with a fitted lid. I mean, plastic wrap will work, but we are going to need to cover it later, and the fitted lids are way nicer to use. Next is some sort of electrolyte solution. Sulfuric acid works well and is readily available at the hardware store. Just always wear proper protection. This stuff will blind you if it gets in your eyes, and it also gives off some pretty gnarly fumes like hydrogen sulfide and sulfur dioxide gas. Then we're going to need to power this thing. You'll see a lot of guys rocking an old school manual battery charger, but really a variable supply like this one is a way better tool for the job, and it's just as cheap on Amazon. This next piece is what is known as the cathode, and that can actually just be the piece of metal being deplated. Really, it's whatever you connect the positive lead to. However, the acid will eat up your clips, so copper is often used as a go-between. I'll be using some copper pipe and mesh to make a basket for some of the smaller stuff. Last is a lead or stainless steel bar to serve as our electrode. Unfortunately, I wasn't able to find this locally, and it was going to take over a week to deliver, and I do not have the patience for that, so I decided I would just make my own. This also gave me the perfect excuse to use my new melting furnace for the first time. I picked this guy up from a company called Gong, however you pronounce that. I found it on Amazon with a lot of great reviews and for a really good price. It only cost me around $125 for pretty much everything I needed to get started. Minus the fuel, of course. I let it heat up for a minute before tossing in some fishing weights I salvaged from an old torn net. Now, it's kind of a waste to use lead with this crucible, but like I said before, I'm super impatient. After letting it melt for a few, I poured it into a muffin tin I volunteered to be sacrificed for this project. My general thinking here is lead is super soft and easy to work, so if I can just get it into an ingot, I should be able to hammer it into shape easy enough. Well, that's the hope anyway. I was also really impressed by the tongs that came with the furnace. They were really sturdy, and I felt super comfortable handling the crucible with them. So comfortable, in fact, you might even notice in some of the shots I'm not even wearing shoes. Moving on, I let my lead muffins sit for a few before dropping them in some water to cool. And I'll be honest, I totally thought they were going to stick to the tin, so I'm feeling pretty lucky at this point. I look over each one and get to work trying to make my bar. Although I only get a few minutes in before I start to realize this could take a while. I even try it with a smaller piece, but in the end I'm defeated, and it looks like I'm back to square one. So I load up the furnace, but this time I try using a different style tin. I think this was a bread tin once upon a time, but I'm not really sure. I don't remember once having ever made bread. Now, my hope here is that it will be easier to start with a piece that's already kind of flat, right? Makes sense. But things don't really go as planned, and as you can see, it gets all messed up in the tin. I'm pretty sure I didn't let it cool long enough, but you live and learn. Third time's the charm. I load this thing up yet again, and because so much got left behind in the last pan, I had to salvage even more fishing weights. My next victim is an old brownie tin that was destined for the scrapyard anyway, so really it's getting a second life at this point. Now, I definitely didn't want a repeat of my last attempt because I'm pretty sure I'm running out of tins at this point. So just to play it safe, I wait a solid 20 minutes to let it cool before trying to dunk it. It seems to have worked and flipped out no problem. I'm kind of glad it went the way it did because this shape is already a lot closer to what I need, and with just a little bit of TLC, with a hammer, it'll become a nice flat bar that'll be easy for me to work with. Now that was probably a lot more work than it needed to be, but I had a lot of fun and in the end I got what I wanted. With that out of the way, I start shaping the copper pipe for my cathode basket. Although, like I said earlier, you don't technically need this. We could just attach the positive lead directly to whatever it is we're deplating. But you might not find this method ideal, like when trying to process small objects or when working with large amounts. It's nice to have the basket. So I spent what added up to a ridiculous amount of time trying to shape this basket into something I'd be happy with, when in reality it doesn't need to be anything fancy, it just needs to make a good connection with the power source. Now that we have all our components, we can finally start putting this thing together. Our lead bar from earlier, and I for one am very happy with how it turned out. It fits just right on the side of the dish and I don't have to worry about it moving around or falling over. And with a few tweaks here or there and a rock, our basket will be nice and secure. I bring out the power source and start getting it ready to connect to the cell. But not before adding our very dangerous electrolyte solution. Again, protect yourself. That means your eyes, lungs, and skin. You should have gloves, a face shield or goggles, and be in a well-ventilated area. A proper respirator isn't a bad idea either. We finish by connecting the negative lead to the lead bar and the positive to the copper. So now the cell is complete and all that's left to do is test it out. But there's one small problem. I have no idea how to operate the power supply. I mean, I'm pretty sure I could probably figure it out from the manual or find a guide online, but I figured it would be more fun to keep pressing buttons and see what happens. This gold-plated CPU I pulled from an old computer tower will be our first test subject. I do know that gold starts to deplete somewhere around 3 amps and at about 12 volts. So I start at the lowest setting and keep slowly adjusting dials until I start to see the reaction I want. That white foaming action on the lead bar is a real good sign that electrolysis is happening, but I think we're still a little under power at this point. So I start impatiently moving volts up and finally hit the sweet spot, and yes, we have gold. The reaction is almost instant, leaving a thick cloud of black dust, which is actually the gold that was depleted from the chip. So now that I know the cell works, I can finally process all this e-waste I've been sitting on. Thank you so much for watching, I hope you liked it, and look out for an upcoming video where I deplate an icon ratchet and another one where I cast an anthill out of aluminum. Should be fun. And don't forget to hit that like and subscribe so I can keep working on fun projects like these.